So hey guys, so today we're gonna make up a mock interview. So I have a friend. So he's from Austria. So I have a friend. His name is Jhonny. So I'm gonna have a mock interview with him. He's my friend where I met in a Pram website. So Pram is something like a mock interview website. So we have Jhonny. So the main intention of making this video is, as you know, I'm trying to do some problem solving skills, brushing up things, right? So I thought of having a mock interview with Jhonny is like a best thing to do. So I thought of I approached him and he agreed with that. So yeah, so Jhonny, would you like to introduce yourself?
Hello, folks. Hello, Sri. Thank you for this opportunity. It's a pleasure to have a mock with you. I have several years of programming experience, was working in the banking software, then switched to the tourism business, but all my life I had a passion to solve some riddles and programming tasks. Therefore, here I am now because these Leetcode tasks and mocks give really a lot of dopamine boosts.
Yeah,
So let's go for it.
Yeah, cool. So basically, the interview format would be for the audience. So initially, Jhonny will be asking me few tasks. So I'll be the interviewee, and Jhonny will be the interviewer. So I have to answer those tasks. And when I'm done with that, when I ace that, so the next one will be swapping the roles. So in the next thing, I'll be the interviewer. Jhonny will be the interviewee. So I'll be asking him three tasks, and he have to solve that. So this is like a normal mock interview. So yeah, Jhonny, we can start it.
Okay, please open the document.
Yeah, I already opened it. Yeah, you can paste them.
Okay, and I insert the tasks. The first one is real warmer up.
Okay.
And I sure that you ace all of them, but this one should be really the fastest.
Yeah, let's see. Sometimes easy also will become difficult for me. So let's see how it goes.
Yeah, let's see.
So yeah, so delete characters. So first let me start by reading the question, and if I have any doubts, I'll start asking. Okay.
Yes,
Yeah,
please.
so a fancy string is a string where no three consecutive characters are equal. Okay. So given string S, okay, now delete the minimum numbers of characters from S to make it fancy. So return a fancy string after deletion. It can be shown that answer will always be unique. Okay, so after reading the description, what I got to know was they'll be giving me a string and we have to make it a fancy string. So where fancy string is nothing but it doesn't have any adjacent characters repeated more than 3 times. So that's what I got after reading the question. So seeing the first example, it has a Leetcode as a string. It has 3 E's, and okay, so that's why the fancy string doesn't have one extra E. Got it. So using the second example, okay, 3 A's, so it changed it to 2 A's, and 1 B that satisfies 4 A's, that change it to okay 2 A's. Got it. Seeing the third example, okay, third example doesn't have any character adjacent, I mean 3 consecutive characters, so it would be the same string. Okay, seeing the constraints, okay, it's s dot length would be 10 power 5. Yeah, okay, so okay, so the normal approach, I mean the first approach which come to my mind is, okay, let me do one thing. Okay, so let me split this out.
On the next page, you can see the place for solving.
Yeah.
So the class and the function is already provided, and then you will be done with it. I will also paste the link to the Leetcode task. There you can test it immediately.
Yeah. So let me start this. So what I'm going to say was, so make fancy string. So the first approach which comes to my mind is this basically what I'll be trying to do is I can just iterate to the string. I mean we'll be having this string, right? So for example in this Leetcode string, so what I can do is, so I'll try to paste it in the solution page. So I'll just dry run this. So this is the input, right? So this is basically the input.
I can see it below.
So I can use like a single linear traversal. So imagine this is a pointer. So imagine we have a fancy string like this, fancy string. So initially fancy would be empty, right? So I'll start from the first. So in this case the first character is L, right? So I'll check whether the fancy string has L equal or not, or Okay, interesting. So it cannot be equal. Okay. Got it. So what I can do is initially I can see if at all fancy string is greater than or equal to 2 or not. So if it is equal to greater than or equal to 2, I'll see the last characters is equal to the current character. So if that satisfies, I wouldn't append this character to the fancy string, or else I'll append to the fancy string. So in this case, let's see. So initially we have L, right? So that actually means fancy is anyhow empty. So I'll just append L to this. So I'll move the pointer
Absolutely.
forward.
Yep.
Now we are having E. So E is not equal to L. So I'll add E. I'll move the pointer. Again, E is equal to L, but the last second character is not equal to this, right? So in that case, I can add again. So it's gonna be E, and again I'll move the pointer to the third E. So now the current character is equal to the last two characters, right? So now I don't have to add it. So I can just move the pointer forward. So now it's time for T. T is not equal to the last character, so I'll just append this. So I'll move again to C. No, again C is not equals. I'll add C. Similarly for O and D and E. So this would be the approach. I mean, like a linear traversal. So this is the now approach I got the beginning. So coming to the discussion of this time, like the for so one second. Okay, time. So what I'm doing is I'll try to, as I'm trying to do a linear traversal, right? So I don't think it would take any much time. It would be a normal order of n time complexity. So the time would be order of n. So because we are doing one single traversal, right? So it would be the length of the given string itself. So it would be just the order of n time complexity. So coming to
Yes.
space. So as we are not, I mean, of course we're not using any other data structure, extra data structure. So like we're not using any hash set or hash map or kind of thing or any other external array. So it would be, but yeah, we are trying to create a new string. So it depends on the it, like I mean, this length of the string wouldn't be a single thing, right? I mean, for example, if the given string contains all e's, in that case the space wouldn't be the length of the given string, right? So we can I guess we can consider this as a constant space, because I guess variables wouldn't count, I guess, right?
Yeah, usually the result doesn't count in
Yeah,
the uh, space which is used, because
yeah,
in this case you cannot get rid of it anyway.
yeah,
Therefore, you can say that since there is no actually a data structure, so then the space is O1. Absolutely right. I
yeah, got
just
it.
wanted to point you on one moment, the
Okay.
approach which you want to use to check characters.
Mm-hmm.
This fancy string and the input string uh, is nice, but if we will imagine that the number of fancy characters will be different, for example, 3 or 5 or whatever, and then it will need you to slightly adjust your code. And also, probably it's not so convenient to check the last elements in the fancy string. Probably you can consider some better approach.
Mm-hmm. Okay, so you mean there might be some better approach than this, right?
Yep, just for the corner cases, let's say then you have in the fancy string nothing or only one entry, it's more difficult to check last two characters,
Yeah,
and
yeah.
therefore you will need to handle it in some special way, but that's not very convenient. And
I can just see if at all the fancy string is greater than or equal to 2. I mean, its length is greater than or equal to 2, then only I can check that, or else I can just move pointer forward.
that's also a good idea. Yep.
Yeah.
So
So
you can be sure that you can take first two characters from the input string by default, and then you can use your approach. Yeah.
yeah, then that's also fine. Then yeah, I'm even that would be okay. So can I assume? Let me see the constraints. So okay, so if I try to take the first two characters and if the length of the given string is 1, then that would be an extra, like an array index out of 1, right? So
Then yes.
that would be an extra case. So in that case, what I'll be trying to do is okay, if at all the given string length is less than or equal to 2, then I would just return the same length, same string. I think you got this, right? So
Yes, that's a
so
corner case.
so if if what I'm trying to say length is less than equal to 2, then I would just like normally return the given s only. So this is the first case which I'm going to do. If this doesn't satisfy, then that actually means the length will be greater than 2. That actually means we can take the last two characters and do that. So yeah,
And compare with them.
yeah,
Yep.
compare it. So I think this works. Okay, so if that agrees, I can start implementing.
Yes, please go for it.
Yeah, so let me remove this. Okay, so this is the given one, right? Got it. So
Could you
yeah,
please keep that time and space for the future, just
yeah, sure.
to have it?
Yeah, got it. So time order of n, and the space is gonna be order of 1. Yeah, so as I said before, I'll be using a fancy string, right? So generally if we can use a normal string, but I'm gonna use a string builder. So string builder is something a bit faster than string, and it doesn't use much space as well. So string builder is something which makes manipulating the strings easier. So I'm gonna use this fancy new string builder. So this is the given first thing. So first thing, as I said before, I'll be checking whether the string is less than or equal to 2 or not. So if s dot length is less than or equal to 2, then I can just return the given s itself, right? So or else I'll be start doing this. So initially I have to append the first two characters to this fancy. So fancy dot append, or else I can do one thing. So s dot substring from 0 to 1 2, yeah, from 0 to 2. This will be taking the first two characters. So this will have the first two characters. So now starting from the third index, which actually means the second one, so what I'll be doing is for int I is equal to 0, I is less than not I is equal to 0, I is equal to 2, I is less than s dot length and I plus plus. So now the thing starts. Okay, so what I'll be doing is now I'll try to check whether if the last two characters is equal to the current one. So if fancy dot fancy dot caret fancy dot length minus 1 is equal to the current character, so it's gonna be fancy dot caret not fancy, sorry, it's gonna be s. So s dot caret I, and fancy dot caret fancy dot length minus 2. So if this satisfies is, and if this is equal to s dot caret I, that actually means the last two is equal to the current one. So if this satisfies, I'll just do continue. I don't know, do anything, continue. Or else now the actual thing starts. I'll just try to append fancy dot append the current character, which is s dot caret I, and at the end I'm just going to return this fancy dot to string. I'm just converting the string builder to string.
Looks very nice. Actually, I'm ready to share the string with the link to the task itself. If you want, you can test it now, or you can test it later.
Yeah, let me test it so I can see this.
Okay.
Okay, cool. So 1 second.
It's a interesting mystery for me now, because your future viewers will see how you test it, but I don't see.
Oh yeah.
But no problem.
This is an interesting thing. I mean, we didn't figure it out. I mean, we didn't think about this. Yeah, so now I might have to remove some capitalizations in this. So
Yeah, returns and continue, if I'm not wrong.
Yeah. And luckily I have a Leetcode formatter. It automatically formats the code for me.
Good.
Yeah. So yeah. Okay. I think seems like okay. Okay, cool. I think let me run this once. Run code. Okay, some compilation errors. Cool. So let me go ahead, run again. Yeah, the Leetcode test case passed. So let me see the other two test cases as well. Yeah, it passed again. So let me submit this. Yeah, cool. It passed. It got succeeded.
Perfect.
Yeah,
So
let
we
me.
got it.
Yeah, so I think we can go to the next question, right? So any other feedbacks for this question? I mean, should we discuss at the end?
Your solution really nice. You
Okay.
work it out. I had a slightly different solution in my mind. This the counter for the characters which are repeated, but it's not uh, like important which solution did I have
Okay.
because the
Yeah.
most important to get the working solution, and you just show me a new approach, and it's also really nice.
Yeah. Yeah.
Just I suppose if we would have, for example, the limitation for the fancy string, not 2 characters but 5 characters, for example, you will also need to introduce a second inner loop to check all the last characters of a fancy string.
Yeah. Yeah.
But still, it's also very legit and nice.
Yeah. Cool.
Yep, let's
Yeah.
go for the next one.
Yeah. So the next question. Okay. Find elements in the contaminated binary tree. Okay. So given a binary tree with the following rules, root dot value is equal to 0, and if tree node dot value is equal to x and tree node dot okay, then if not left is not equal to null, then left value will be okay 2 into x plus 1. If okay, similarly for the right, but 2 into x plus 2. Now the binary tree is contaminated, which means all tree node dot value have been changed to -1. Okay. Find elements. Okay, this will pass me a root. Initialize the object with okay, then recovers it and find. Returns true if the target value exists in the recovered binary tree. Got it. So yeah, so I got it. So what they're trying to say is they'll be giving me a root where initially it contains all the values as -1, -1, and I have to recover it in such a way that if at all the root value is x and its left side root is left side I mean the child value will be 2 into x plus 1. Similarly for the right it's going to be 2 into x plus 2. So that's what they're asking to. First I might have to recover the values and then see for each and every call of this find method. I have to see if the target exists in a tree or not. If that exists, then have to return true. If it isn't, then I have to return false. So that's what the question I got it. So let me see the example. So initially the negative -1 and recover 2. Okay, root dot value is 0, so it's 0 and its left and right would be okay, got it. The right side 2 into 0 plus 1, 0 plus 2.
Yeah, the left supposed to be 1 if it would be present, but since
Yeah,
it's not present,
yeah, got
we
it.
have only the right element. Yep.
So the queries are asking find 1 is not there, so it's returning false. Similarly for 2 is there, so it's returning true. So if I see the second example, okay, 1 2 and 3 4, so got it. So I think okay, I got it. So what I can do is basically I can do a normal traversal in a tree, like a normal traversal, starting from the root, and I'll initially assign the root's value as 0, right? So now I'll try to see first of all if the left is present or not. So how can I see that? So I can see basically by seeing if the left root dot left is not equal to null. So if that satisfies, that actually means there is a node, there is a left child. So if there is a left child, I'll assign its value as 2 into root dot value plus 1. Similarly, I'll see for the right side node, if root dot right is not equal to null, if that satisfies, I'll assign root dot right dot value will become 2 into root dot value plus 2, and I'll go to the left subtree again. See, like a normal pre-order traversal, I would say, like a pre-order traversal. So, and this is basically going to recover the entire tree. So imagine so coming to the page, this page where I'm going to write the code. So imagine we have some method called as recover. So imagine it's called as recover. It look like public void recover. Oh, we're still getting the capitalizations. 1 second. Tools, preferences.
I'm not sure that it has to be public for this task.
Okay, got it. So void, maybe like recover. So this is going to recover the entire tree for me. So I'll tell you what I'll be implementing in this later. So I'm going to write this in this. So and then after recovering the values, I'll be storing. Okay, let's start with initially. So after recovering this, whenever I call this find method, I can traverse the entire tree. I can do any of the 3 traversals, like pre-order, in-order, and post-order. And I prefer pre-order, so I can do pre-order traversal for the entire tree. And if at all the current value is equal to target, and I can just return true from there. So that would be the one approach. So I mean, let me analyze it. So initially, as I said, I'll try to recover, right? So imagining the number of nodes the tree contains is n. So imagine if like if it is n, like number of nodes is n, then the time complexity for initially, as I said, I'll be recovering, right? So for recovering, it's gonna take order of n, of course, because I have to traverse the entire tree, right? So and after that we have to call, they'll be calling me find method, right? For finding, as I said, I'll be traversing the entire tree and see whether it is there or not. So for that, it has to traverse the entire tree in worst case. So it's going to take order of n again. So combining this, it's going to take like order of n time complexity. But actually, I can try to rectify this order of n here. So actually, what I'm trying to do is I can use a set actually. So when I try to recover the values, I can store them in a set, like a hash set, like maybe which looks like this, like a hash set which contains values of type integers, right? So whenever I recover a value, I'll try to insert them in this set. So whenever the compiler or something calls this find function, I can just see whether this set contains this target or not. So if that contains, then it will just return true, or else it will return false. So basically, searching in a hash set takes constant time. So if I take it as a consideration, then I can just say this is going to take order of 1 for finding, and for recovering is going to take order of n time complexity.
Absolutely right. Therefore, in this situation, we have a trade-off. So we can spend some more space, right?
Yeah.
Because initially, your first solution there, you did not use hash set, then your find was on, but extra space was constant, since you didn't use any extra space. But then you start using hash set, which potentially can have also on space. You really speed up the search.
Yeah, so coming to the space, as we have discussed again, so I've just said I'll be using a set, right? So in worst case, or not in worst case, absolutely we're gonna store all nodes in this set, right? So obviously,
in any case it will be.
So it's gonna be of n time, in order of n space complexity because of the set.
Good.
Yeah, so is this approach okay?
Yes, they both are okay, but I suppose that the approach this set will be more interesting since it's much faster.
Yeah. So yeah, if that okay, then I'll try to implement that, if that's okay.
Yes, please.
Yeah, sure. So as I said, let me remove this first. So this is going to send me a tree, right? So first I have to recover those values, converting this minus ones to some meaningful values. So for that, what I'll be doing is as I said, so it's going to be void recover. Sorry for this bad indentation. So tree node root. So what I'm doing is first I'll assign the root dot value is 0, as the question says root dot the value is equal to 0 only if root is not equal to null. I don't know whether root might be or may not be null. Let me see the constraints once. Okay, so okay, there is at least one node, so I think in that case that won't satisfy. But yeah, I can remove this. Root dot value is equal to null, and I'll start call the recover function. So recover the root. So what this function is going to do, so what I'll be doing is initially if root dot left is not equal to null, then I'm going to do something. And similarly okay, so if root dot right is not equal to null, I'm going to do something. So I'll tell you what I'm going to do here. So if root dot left is not equal to null, so I have to like assign a value. So root dot left dot value is gonna be 2 into root dot value plus 1. So similarly for the right, root dot right dot value is gonna be 2 into root dot value plus 2. And as I said, I'll be preferring pre-order traversal, right? So when I assign some value, I'm gonna go to the left subtree. So it's gonna be recover root dot left. Similarly here, after you're done with the left subtree, I'm going to the right subtree. So recover root dot right. So this only goes towards the left or right only if it is not null. So if it is null, it doesn't satisfy. It doesn't go towards the left subtree and right subtree. So I guess this is going to recover me the tree. And as I said, I'll be using a hash set, right? So for that hash set, so hash set is going to be of type integer. So let's name it some meaningful word, set which contains some nodes. So recovered nodes, like that. So after I think we have to do before only. So recovered, so recovered nodes is gonna be new hash set. So now when I recover some node or when I recover something, I have to add that in that set, right? So initially I have to add 0. So recovered nodes dot add 0. Initially 0 is the root, right? So 0, and then I'll go towards the recover method. And when I'm done with this, I have to add this to the set. So recovered nodes
Wait a
dot
second, please.
okay.
You don't need to call it so many times, because just take a look. You will call recover once for every node, right?
Yeah.
Therefore, you can add the value of this node only then you have this function called for this node, and that's it. I mean,
again.
if you recover some node, at the start of this method, you have the value of this node, and that's the best moment to put it to the hash set. Therefore, you would not need it to specifically left or specifically right.
Actually, I didn't get that, but you're trying to say not here, but here,
just
right?
Finish your solution.
Okay.
Let's finish and check it in Leetcode later, and then
Yeah, sure. So recovered nodes dot add root dot left dot value, and similarly recovered nodes dot add root dot right dot value. So this is going to add the nodes, the recovered nodes, And coming to the find method, now the thing starts finding. So return recovered nodes dot contains the target. So this is gonna make the true or false condition. So if it is there, it's gonna return true. If not, false. I think, yeah, this is pretty much my implementation, unless there are no
Yep.
compilation errors. Yeah,
Implementation of find function is the most pleasant part of this.
yeah, yeah. So let me copy
So
the
here is
link.
the link. Yep. Please test it.
Okay, cool. Let me paste the code as well. Okay, so 1 second, I'll try to paste. Okay, copy C. Okay, let me try to run this once. So run code. Okay, some compilation errors recovered. Got it. And start of expression. Okay, some weird compilation error. Illegal start of expression. Okay, okay, I got it. Got it. I missed the extra bracket. So okay, the sample one passed. Let's see the extra example test case as well. So run code and yeah, let me submit this and see whether it works. Yeah, it got succeeded.
Perfect.
Yeah,
So you did a really good finding both solutions and finding the trade-off between time
okay,
and space. So one small, let's say, cosmetic note, you can
okay,
try to adjust your solution right now in the Leetcode. Uh, you can put the addition of node values to the first line of recorder before you check the root left null or not. You already have the root and you have the value of it. So only in this place of the code you can just recover nodes at node val and remove it from all the rest.
got it, got it. So it's gonna look like,
Because this recorder function is called for every node, and as soon as you call it, you already have some value defined. Yep.
yeah. So let me once try to run that. I have changed that. Yeah, I think
Yep.
it succeeds. 1 second. Yeah, that worked as well. Yeah, cool. Shall we go to the next question?
Yes.
Yes.
This one is really has a big explanation, big
Okay.
description,
Got it.
but
Got it.
should not be too difficult
Okay.
to deal
Let's
with
see.
it.
Hope everything goes well. So yeah. So there is an end-to-end zero index grid with some artifacts buried in it. Okay. You are given the integer n. Okay, and the zero index 2D array where artifacts description position of rectangular artifacts. Okay, denotes that the ith artifact is buried in the subgrid where is a coordinate of the top left corner and okay bottom right corner. You will excavate some cells of grid and remove all the mud. Okay, from them. The cell has a part of the artifact buried underneath. It will be uncovered. If all the parts of the artifacts are uncovered, you can extract it. So given okay, dig off.
The main idea that if you excavate artifact has a bigger space, that means that you still don't have the full artifact yet.
Okay, let me read this
And
and let's see. Yeah, indicates that you will excavate the cell. The number of artifacts that you can excavate. The test cases are generated such that no two artifacts overlap. Okay, each okay, most Let me see. I can get the question, but let me see the example. What it's trying to say. So okay, this is one artifact. This is one artifact. Got it. Mhm. Okay. Okay. So in this example, n is 2. Artifacts are saying 0 comma 0 is the top left corner and 0 comma 0 is the bottom right corner. Okay, 0 comma 1 is the top left corner, 1 comma 1 is the top bottom right corner.
You can see these artifacts as colored rectangles. So
Okay.
the red rectangle is the first artifact, and the blue rectangle is the second artifact, which slightly bigger. And since we dig the top left corner and top right corner, the result is 1 because we can dig the smaller artifact, the red one, completely. But for the blue artifact, we dig only its top part, but not the bottom, and therefore we cannot pull it out of the dirt.
Okay. Okay. Let me see a second example. So 0 comma 0, that's obviously 1, so we can take entirely. The next one is 0 comma 1, 1 comma 1, and we are digging the 2 entire thing. So got it. So
in this example, we dig everything,
yeah.
exactly all the possible, or not possible, all the required cells to get the artifact.
Got it. So basically, what I can do, I mean, the approach which I got in my mind was, I mean, the thing which I can do is, this is basically like a top left and bottom right corner, right? So what I can do is, starting from the top left corner, which is 0 comma 0, like this, in this format, like a top left corner cell, and the till the bottom right corner cell, I can do like a nested for loop, and put some color to it, like just put some color. In this case, it's 0 because this artifact index is 0. Let's assume I'll put some
The
0.
first one.
Yeah, first one 0. So similarly for the second one, I'm gonna put ones for them. So I'll try to iterate from this dig method. So when I try to dig like for example 0 comma 0, I might have to, one second, I might have to change the color, or let's do one thing. Okay. Okay, got it. So let me do one thing. So when I try to change the color to zeros, so what I can do is, for example, I can use a hash map. For example, I can store the number of colors are there. I mean, for example, in this case, there is only one cell, right? 0 comma 0 to 0 comma 0. I think you're getting right. Can you hear me?
Yes, I can hear.
So
and, for now, if you allow me to give you a small suggestion, you started slowly moving in a not the best direction, let's say. I can tell you that you don't need to separate the artifacts with some color or with some map. That's a small hint. You should approach it from the other side, let's say.
Okay. Got it. So let me think. So no colors. So basically what I can do is maybe
let me tell a couple more words. You can know if you can extract some artifact or not, then you know if you uncovered all its elements. But when you dig, you don't know for which artifact do you dig, right?
Yeah.
Therefore, but let's imagine in reality, how would you do it? You would dig here and there, everywhere, let's say, and only later you will be checking if you can extract some artifact or not. I think that's why they intentionally switched the positions of artifacts and dig, but you should start thinking from the dig first.
Okay, I can do one thing. So as I'll first try to iterate through this dig method, right? I mean dig array. So initially it's 0 comma 0, right? So I'll place some value in this 0 comma 0. Imagine it's -1, it's -1. And similarly at 0 comma 1 I'll place a -1, and 1 comma 1 I'll place a -1. So now after doing placing all the negative ones in these dig locations, I'll try to iterate through these artifacts. I mean, for example, in the first case, 0 comma 0 to 0 comma 0, I'll make sure everything is negative. If everything is negative in that, then that's a complete one. I mean, that counts. If at all it doesn't counts, if at least one is 0 in that, then that actually means that part is not digged. So then that doesn't count. So
Yep, you got the idea. Absolutely right. So that's the way to go. You need to check which cells were digged, and then to check if artifacts has all its parts digged out. Just one more note. Do you really need a number to know if something was digged or not? Probably you can use more simple data type.
maybe a true or false kind of thing. How about that?
Yep.
Yeah, so maybe I can use a boolean one. So if initially a boolean array would be of type if it, by default every element, every cell will be false, right? So if I dig something, I'll assign it as true. So if I try to iterate through an artifact, all the cells should be true. If that satisfies, that counts, or else that doesn't count. So how about that? So
That's brilliant. Yep. And I think you can go for coding.
yeah, sure. So let me start with this page here. So we need to go deeper, okay? So as I said before, I'll try to iterate. So before that, I'll have to create a board which is of type boolean. So let me see what is this n. Says 2. Okay, it's a 2 into 2 matrix. Oh, got it. So I said I'll be using a grid, so it's gonna be a grid in boolean grid. So boolean grid is gonna be new boolean of, oh, it's of 2 dimensional, sorry. So 2 dimensional, so it's gonna be, why am I going downwards? So it's gonna be n comma n. So now the main thing starts. So I'll try to iterate to this dig array. So starting with the first one, for int maybe cell from this dig. So now I'll try to dig this. So how can I dig that? By assigning it to true. So grade of cell of 0, cell of 1 is gonna be true. So this loop gonna make true for all the dig places. And now the thing starts. So iterating through the artifacts. So basically I'll use the artifact. So int artifact, from the artifacts. So what I'll be doing is starting from the first, I mean the top left and bottom right. So if I take I'll try to make it a bit understandable. So in tr, which is top row, or let's say top row, so it's going to be artifact of 0. So in tc, top column, is going to be artifact of 1, right? So similarly bottom row, okay, sorry for this indentation problem. Int bottom row is going to be artifact of 2 maybe, and similarly int bottom column is going to be artifact of 3. Yeah, so now starting from top row to bottom, I mean top left to bottom right. So for int I is going to be tr, I is less than equal to, okay, this is interesting. So till where I have to do that? Okay, till br I plus plus, and the second loop for int j is equal to tc, j is less than or equal to bc, j plus plus. So I have to make sure everything is true in here. So now the thing starts. So if not grid of I comma j, if it is false, I'll try to, okay, I'll use a variable maybe like boolean, okay, like that. Initially it's false or initially it's true. So if then side, if anything is false, then okay will becomes false, and I'll try to break from there. So it's gonna look like this, break, and I'll check in the second, the after ending the loop. If okay, then what I'll be doing is I'll try to increment the answer, and for that I might have to create an answer variable for that. So it's gonna look like answer is gonna be 0 initially. Yeah, so at the end, so where is the last bracket? 1 second. Okay, last second will be the last. Okay, this is the one. I'll just return answer. I think, yeah, this is the implementation.
Okay, couple moments to point on. I suppose that your internal loop, which sets OK to false, then it will break.
Okay, yeah.
It will, please see, it will go to the if OK, and even worse, since you introduced the boolean OK true inside of the first loop.
Okay, I think I might have to do the outside loop. Sorry. Yeah.
Yep, you could get the incremented answer for many times.
Yeah. So this
answer.
checking should be outside the two nested for loops. So it's gonna be like this. Oh, where's the copy? Yeah, I might mess up with some brackets, but I can adjust that in Leetcode. But if this,
you don't need bracket for this if actually.
Oh yeah,
that's okay because it's one-liner.
Yeah.
I just want to tell you one small trick regarding such checks with some boolean variable and for loops. You can add in every loop the condition to the condition and OK, and it will help you to avoid usage of break.
Okay, got it.
I mean, right now there you check if I less or equals to br, just to the same part of code you can add and OK, and that's it actually.
Okay,
and
that's
the same for the next for loop.
Got it.
So I can give you the link.
Okay.
No, we should shortly discuss the time and space complexity.
Yeah, I forgot that. Yeah, so let me start the time. So coming to the time. So first, initially what I have done, I have tried to iterate through a dig array, right? So dig, let me see the constraint of the dig array. So it might be in the n elements, right? So it's minimum of n square or 10 power 5. So in worst case, okay, minimum of n square. So yeah, the time complexity also would be minimum of n square. Okay, n square is nothing but the number of elements in this grid, and that 10 power 5. What is 10 power 5? Oh, okay. At max there might be 10 power 5. That's what they meant, right?
That's just some constant limitation here, but we can say that still n square is a proper definition.
So got it. So in worst case, there might be a case where we take all the cells n square, right? So that's the reason there might be a case where the dig length will be of size n square. So I'll be iterating through the entire the length the array, right? Dig array. So I'll be making order of n square, right? So n square, I'm just editing it in this for loop only. So this is going to take order of n square at max. And coming to this, let me see the artifacts length. So it's artifacts length. Okay, it's also the same. So can I consider this as n square as well, the artifacts as well?
I think it seems so, yeah, because potentially it could be that all the artifacts, they cover all the grid.
Yeah.
So, or we have one huge artifact which covers all the grid, having
Got it.
this in mind, we will need to traverse in the internal loops of all this board, all this grid.
Okay.
Therefore, yes, you will consume both space and time as n square.
Yeah. So even here it's gonna be n square, I would say. I mean, in the worst case, in these artifacts as well.
Good.
So if I combine all of this, so the time I'll write down at the bottom. So time is gonna be n square, and coming to space, as I said before, I am using an extra grid, right? So of size n square. So that's also it's gonna take n square.
Yeah, perfect.
So this is the time and space. So shall I try to run this?
Yeah, please try. Probably there will be some issues with the brackets or some code,
Yeah.
but hopefully not. As far as I can see, your code is quite clean.
Yeah. Okay, so let me copy this entire thing. Okay, I'm going to copy. Okay, this has become a mess, but let's try to run this. Okay, I made 2 compilation errors. Okay, true. Where it went wrong. Okay, one bracket is missing. Got it. Okay, the example one passed. Let me try with some examples. Okay. So yeah, even these passed. Let me submit this. Yeah, it got succeeded. Cool.
Perfect.
Yeah.
I see you didn't add the trick, this update of condition. May I show it to you?
Oh yeah. Can I? Let me see that.
So I have selected the line. Can you see it?
Yeah,
No?
yeah. I can see it.
Okay, so now you could do it like this.
Hmm?
And here like this. And therefore, as soon as you say that, okay, it's false, it will automatically kick you out of both of these loops. Therefore, you would not need this break.
Okay, got it. That's nice.
Just a small trick, but maybe
Yeah,
it will
yeah.
be useful for you one day.
Yeah. It's useful, of course. Yeah. I think I'm done with my
So,
role, right? Right.
you very nicely aced all of the tasks.
Yeah. So
Was a
any feedback?
pleasure. I would hire.
Do you hire? Okay.
Hey,
What's my CTC and what's my role?
that's a good question. I think developer.
Okay. And how about the CTC? Monthly.
No, we need to discuss it with the boss of the company, not with me. Sorry.
Okay. Okay, got it. So yeah, and so now I'm done with my tasks. So now I'll try to share you some tasks, 3 tasks. So now it's time for you to become an interviewee. I'll be the interviewer. So let me take the questions. 1 second. Hold on.
Yep, I will try to open the doc.
Yeah, did you open that?
Mm-hmm. Okay. Okay, looks really interesting. So, first unique character in a string.
Yeah.
Given a string, find the first non-repeating character in it and return its index. If it doesn't exist, return -1.
Yeah.
1 second, my daughter is attacking me.
Yeah, that's okay.
I'm sorry. So, okay,
That's
I'm
okay.
starting now. So we have a lead code and the output is 0 because the L is the really first unique character.
Yeah.
Clear. Then second example, love lead code, and here the output is 2 because character V is unique one.
Yeah. Yeah.
L we see several times, O we can see several times, and V is the first unique. Okay. Then AABB gives us output -1 because all of these characters are not unique.
Yeah.
So I see one brute force, let's call it like this, solution.
Okay.
I will need to have a set of characters at all as it is. So I will
Okay.
put into it all of the characters.
Okay.
And I will also need to have another set of unique characters.
Okay.
So as soon as I meet some character for the first time,
Okay.
or vice versa, second set should be for non-unique characters. As soon as I meet any character, I put it into the first set.
Okay.
And I check if I meet the same character once again and I know that it's already present in my first set, then I put the same to my second set.
Okay.
So then I will traverse through all the string. I will have two sets. One, all the characters which were used in that string, and another one, the characters which were used more than once.
Okay.
Therefore, on my next traversal, I will be checking if some character is not present in my second set. So the first one character which I meet will have the index, which is actually result for this task.
Okay.
Therefore, the space complexity will be ON because
Okay.
potentially all the characters can fit into that sets, and the time complexity will be also ON because I will traverse through the string potentially twice, but it's still ON. So is it legit? Can I try to go for it?
Yeah, I mean, so let me clear things again. So you're gonna use a set, two sets, right?
Yep.
Don't you think can we do it in a single thing? I mean, not a set, maybe some other data structure.
Potentially, we can have a map where we would store how many times we meet some character.
Yeah.
And since S consists only of lowercase English characters, we can also use, for example, the simple integer array
Yeah.
where the size will be 26, so the space will be constant.
Okay.
Yep, and then the value of each index will be how many times did we meet this character.
Okay.
And therefore we would not need two sets, you're absolutely right. We will just need on the first traversal fill in this array,
Yeah.
and on the second traversal check the first character which has corresponding to its index value as 1.
Yeah.
Because it will mean that it's unique. Thank you. Awesome suggestion. Just the idea with two sets potentially could serve to input with any characters, but thank you that you pointed me on the constraint that S consists only of lowercase English letters. Therefore, we can really consume much less space.
Yeah. Yeah. So you say you are going to use an array, right, for making the frequencies of the character.
Yep.
So
So I would say
imagine. Yeah. Okay. Okay. You continue. Go ahead.
space will be O1.
Okay.
Because we have a constant space and the time is going to be ON, because we really need to traverse through all the S length.
Okay. So don't you think array would take an extra space? I mean, you're trying to use a space of 26 size, right?
Yeah,
So
then we call it 26. It's usually considered as a constant. Yep.
okay. So okay, imagine you have an input which looks like maybe like this. So
Yeah.
imagine A, and Z. So in this case also you're going to create an array of size 26, right? So in this case all the cells like for B and for C and for D will be empty, which is not used at all. So don't you
Yep.
think
But
that would be a waste of space?
no, I don't think. Actually, for this input, the solution with two sets will be more convenient, and it will take less space, but it all depends on the input.
Okay, okay. Then I can go ahead with the array one. I'll tell you what I was
Yeah.
thinking of. Yeah, first you can go ahead with this approach. Yeah, you can implement that.
Potentially, I can go also the solution with a map.
Okay.
Then for every character, I will have a counter of the entries. How many times do we have this character? But
Okay.
I think that array is more simple to implement. But okay,
Yeah, yeah. You can
can
go
do
ahead.
both. So int frequencies. As I say, I would go for the map or for the sets if I would know that we have more than 26 characters. But since we already know it, it's
Yeah.
really nice to use it. Good. And actually, we don't need brackets because we can simply say that freaks from ch minus a plus plus. That's it. Should do the trick. Actually, I can keep it on the same line.
Okay.
Then we have our input data prepared.
Okay.
We can here return -1 immediately if our next traversal will not give us some positive result. And the check is again the same.
Okay.
I could introduce in the meanwhile the array for the S, but not a big deal. So here again we just have a single liner. If freaks from ch minus a equals to 1, oh, like this I think, then we can immediately I made one mistake, of course, the dummy mistake. You can see it length because I really need to know the index.
Yeah.
So, and now I can do it like this. Close it, return I, and I will need to introduce character ch. So, should be it. Let me recheck it shortly. Introduce
Okay.
the array, then I fill in this array.
Yeah.
So then after filling in, I start checking.
Okay.
I'm having the index in my hands, and then as soon as I meet sum which equals to 1, I return. Yeah, looks legit. So if you will give me a link, I can give it a try.
Yeah, looks good to me as well. So let me get the link. 1 second. Actually, I didn't have the link. Let me get that. 1 second.
Since I don't share my screen with you, you will
Yeah.
also. Don't know.
Yeah, it was running.
Because,
Next time we'll plan something which looks like where both of us can see that. Everyone can see that. So yeah, let me paste the link.
actually, I can share my screen with you. Should I give it a try?
Okay, let's do that.
So I start a screencast of my screen.
I've shared the link.
Yep, I have it. Ta-da! I have the feeling that I was solving this task some time ago. I know that I shouldn't tell it in the real interviews,
Yeah, but that's okay.
but oops, of course the indentation are really spoiled, so short fix. Do you see the screen normally?
Yeah, I
Is
can
it
see.
good?
Yeah, it's good.
So I run the example test codes. Looks good. So I can
Yeah,
try to submit.
yeah,
Yeah, we can see that I was solving it
yeah,
slightly
yeah,
more than a year ago.
yeah, yeah.
Good,
Yeah,
that's it.
let's
So I
continue.
close it and we go for the next one.
Yeah, yeah, we can go ahead with the next one.
I can keep sharing or I can stop sharing. Just guide me.
Yeah, yeah. You can. That's okay. You can stop.
I can keep it. Yep.
Okay, you can
Okay.
stop or you can keep anything. That's fine.
Ah, let me keep. I just know that you know what I'm doing, and
Okay,
now
okay,
also the viewers will see how I was looking at this.
okay. Then
So
let's
next
go.
task, populating next right pointers in each node. Oh, my lovely trees. You are given a perfect binary tree where all leaves are on the same level. So we will not have some leaf somewhere below which doesn't belong to a full level. Okay, and every parent has two children. Nice. The binary tree has the following definition.
Yeah,
Okay, left, right, and also next. Okay, but as far as I can see, for every rightmost node, the next one is null. Good.
yeah,
Populate each next pointer to point to its next right node. If there is no next right node, the next pointer should be set to null. Initially, all next pointers are set to null.
yeah,
Therefore, the idea that I need to connect these 2 and 3, 4 with 5, 5 with 6, and so on. So, given some input,
yeah.
I feel that I have some kind of level order traversal
Okay,
because DFS doesn't look legit for this situation.
okay.
And given the above, your function should populate to its next right node, just like in figure B. So if I have no root, I can say nothing to do, and there could be 4,000 of nodes. Okay, with values from -1,000 to +1,000. Actually, this constraint makes no sense at all because I don't care about the values, right? I
Yeah,
care about only the positions, and
yeah,
the number means that I should do it really gracefully and not waste much time. Okay, you may use only constant extra space. Good, nice. And the recursive approach is fine. You may assume implicit stack space doesn't count as extra space for this problem. And here we have the
sorry.
solution, but I will keep on the left side this example just to keep
Yeah,
it clear for me how it
yeah,
will go on. So, for the root, I don't need to do anything. That's really an easy start. But then the fun starts. So obviously I can see that for every node, if it has child, it means that it has not only one child, but at least two of them, since the tree is perfect.
yeah,
And the easy thing here that I can say for every node and which has childs, that its left child right pointer should point to the right child. So
Yeah.
for node 1, I can immediately say that 2 points to 3 because I have everything in my hands. And the same is for nodes 2, 4, and 5. It will be really easy to populate the right node for 4 and for 6. But the tricky moment here, how to populate 5 right node.
Okay.
So give me several seconds to think
Yeah,
about
you
it.
can take your time. Yeah.
Yeah. So then I start. How would I do? Just let me try to imagine that I do it in reality and I go for it one by one. I
Yeah.
take the root and I apply this approach. So I say for 2, the right pointer to 3, work it out. And for 3, the pointer to the next node should be null. So it's okay.
Yeah.
Then, then I go deeper. I can say for 4 points to 5, it's okay. And actually for 5, I will have to fill this right pointer only if my root has something to the right of it.
Yeah.
Otherwise, there will be no sense. I mean, for 7, we don't need to fill it in,
Yeah.
similarly to 3. Therefore,
Yeah.
we can say that if 2 has a right
Yeah.
pointer, and it's already connected actually, right? Because we connected it in the previous step.
Yeah. Yeah.
Then we know that we can get from 5 taking the right node of its root, of its parent,
Yeah.
and taking the left node
Yeah.
of the, like from 5 we go to 2 to 3 and then to 6.
Yeah.
Yep, and then we can point from 5 to 6. So that looks like a way to go, and we will not use any extra space.
Yeah.
Just the last thing which left to write it nicely.
Yeah.
Because when I say it, I kind of feel it, but let's see how it will be in the code. And regarding the time and space, yeah, as we discussed, there will be no extra space because I don't use any other data structure but the initial one.
Yeah.
And regarding the time, for every node, I will take one time, let's say, because there will be no nested loops.
Okay.
So I can say that we have n nodes and the time will be on. That's it.
Yeah. Yeah.
So space o1, time on. Well, for the root, connect node root.
Okay.
So I think if I need to introduce one more function or if I can reuse the same one.
Yeah, you can go anything anyway.
In the end, I will have to return the root. So
Yeah.
let me write return root immediately.
Yeah.
So
Nice.
if the node is null,
Yeah.
then I should do nothing. So if root equals null, return null. Then also it's interesting how should I do it between 2 and 3. Then I filled 2, the connection between 2 and 3. So just to keep it simple, if node left not equals to null,
Okay.
then we can say that how did they call it? Next. Yep.
Yeah. Next.
Next, just to make it properly. So then I can say that node left next equals to node right.
Yeah.
Therefore, I know that I have now 2 and 3 connected.
Yeah.
Then, actually, I don't need to check if node right not equal to null. That in such a case, I know that node right also not equal to null. And then
Yeah.
I can say that node right. Here we have a question if the present node has next or not.
Yeah.
If node, because otherwise it makes no sense to do it.
Yeah.
If some node has no next, nothing to do. If not equals to null, then we will fill, ouch.
That's okay.
Then we will fill in its node right next equals node next left. So far so good, right?
Yeah.
Sounds legit. Then I also think that we need to make one step to the next. So we should say that we want to connect root next, right? Because then I will finish this node 1.
Yeah.
I will go at some point below, so I will call connect root left.
Okay, interesting. Okay.
Let me think about it. Actually, no, I don't need to call connect root next. I can just call connect root left and connect root right. And actually, it makes sense to call it also only if node left not equals to null, right? Otherwise, it would make no sense.
Okay, let me see. Connect root left. So it's gonna connect. It's left to right. Okay, it's gonna be the.
We start. Yeah. Then for next node we connect it, and we say for node 2, the next node will be node 3. Then node next for the root will be null, so we would not come in. And then the next story will be connect root left. So we will jump in here. We will be in node 2, having already the connection with node 3.
Okay.
So we will connect node 4 with node 5.
Okay.
But now we will also have the connection between nodes 2 and 3.
Yeah.
Right? Therefore, then we will call connect. This one code will be executed because for node 2, node next, not null. So we will be able to say that 5 now points to node next will be 3 and left will be 6. So 5 will be connected with 6. Then I will call connect root left, connect root right. So I will come to the 4.
Okay.
Actually, at this point, it's already connected with 5, but I will be checking only it kids. So we'll do nothing for node 4, we'll do nothing for node 5, and get back. And then from node 1, I will go to connect root right to the 3. So looks legit. I would give it a try.
Yeah. You can try to. Yeah, I'll try to share the link. Okay, so paste it here.
Cool. It's Java, not a Kotlin. Okay, and not node, of course, root.
Yeah.
I'm so bad with it. We started with the root, so root has to be
Maybe
everywhere.
you can change it to node instead. Okay, that's okay.
Yep, work it out. So need to take it back with me just to keep the proper solution and
Yeah.
submit.
I wish Google Docs has this indentation. Cool. Great. Got succeeded, and yeah, that's cool. I think we can go to the next question.
So last one, word break. And here you already have the link.
Yeah.
So given a string S and a dictionary. I remember this title.
Yeah.
And I don't remember how difficult it is. I mean, probably I was already solving it, but I will need to remember because all of this stuff I was doing around a year ago.
Yeah.
So given a string S and a dictionary of strings word dict return true if S can be segmented into a space-separated sequence of one or more dictionary words.
Mm-hmm.
Note that the same word in dictionary may be reused multiple times in the segmentation. Okay, so in fact, I can know that I can reach, let's say, some point in the word, right?
Yeah.
In simple words. And the main question, if I can finish from this point.
Mm-hmm.
Therefore, every time then I can get for this Leetcode, it's important to know, like, if I will be able to reach this position, I will be able to end.
Yeah.
Okay, apple, pen, apple, and words, apple and pen. Yep. So I can just tell to myself that I can reach this position. Pen will
Okay.
not give me anything, but yeah. And then I will have to consider the same starting from this position and so on. Okay, and then the last cats and og. Cats and dog. So here this and kinda other laps with dog, and therefore we cannot finish, right?
Yeah.
That's the idea. That's the idea. Therefore, we can try to go to cats, and then the rest will be and dog, and or we can go to cat, and then the rest will be sand dog, right? So
Yeah.
actually, we have two possible options from the start.
Mm-hmm.
And then for the one of these options, we will go for sand, and we
Okay.
will try to check OG, and it doesn't fit. And the same if we have cats and. So the size of the string is less than 300, but we can really have a lot of words. Okay, and the length of every word can be 20 characters.
Yeah.
So looks really scary. I will need to.
Take your own time. Like this question, you can first tell me about the brute force, and if that satisfies, then you can go ahead with the brute force as well. So as you're trying to deal with some medium questions, right? So even brute force works. Yeah, you can go with this. But it may not work in Leetcode compiler. But yeah, as an interview, you can go with brute force as well for this question. But if you want to even optimize that, you can optimize that.
So, in fact, if I will end up with a positive solution, doing DFS, for example, it will be already good, right?
Yeah. Yeah.
True. So, obviously, I will use memoization.
Okay.
I will, starting from some index, I will be checking if any of these words fit into the rest of the string, let's say. So let's imagine that we are past the cats already, and
Mm-hmm.
then I will be checking which string from this list can help me further.
Okay.
And if some of them works, I will go further and so on. But also, then I finish all the checks, and if I will go till the end and find out that I cannot finish normally, in order to not repeat the same computations again and again, I have to write down that this specific index doesn't lead to the result, and therefore I need to use memo and say that this is like a way to know where. So
Yeah.
if I will come to the same index using some different way
Combination.
up
Yeah.
to it, combination from before, yeah, I will be able immediately say that no, we are done with it.
Got it.
So that's the way to go. So I will start from the index 0. I will
Okay.
have a helper function. To
Got
this
it.
helper function, I will be passing the index where we start from. Of course, I will have to put all the word dict. Then I will be checking if the substring starting from that index corresponds to next word in the word dict, and if yes, then I would call the same function recursively but with a new index. Just it will be a sign that I can reach this index and I can go further. That's it. And then at some point I can either get a positive result, and then I will recursively return true up to the start, or if I don't get positive result, then I will memorize all past indexes that they are, let's say, bad. They don't lead to a good result.
Got it.
So seems that's it.
Yeah, I've got that
Can you
picture.
give me a signature, please?
Yeah, so I'm sorry, I forgot that. Okay. Got it. So yeah, so
If
it's
you're okay
gonna.
with such approach, I mean, can I try to implement it?
Yeah, that looks good. That looks legit. So let me give the signature. Yeah, this is the signature.
Uh-huh. So it's not an array but a list, but doesn't matter. So it will be private helper function. It will take the same string s. Actually, it will take int e, string s, and the same list.
Okay.
So all the magic will happen in there. Here I can simply say, and for memorization, I will need to use the set of integers, probably. So if some index fall into that set, it
Okay.
means that this is a bad one.
Okay.
So I will call it integer memo, or just call it bad
Okay.
to keep it simple. If some bad indexes,
Yeah.
if someone in there, then we are in trouble. So we can say return starting from the index 0, passing the same input string, passing the same word dict, and passing the new hash set, because initially it should be empty.
Okay.
That's it. So all the rest of the magic will happen inside.
Got it.
So then do we stop? First of all, we stop if bad indexes contains I.
Okay.
We can immediately return false. And I forgot to define the return type. It has to be Boolean. Yep. Also, we will return false in the end if we not succeed in the meantime. Therefore, just to not forget the memorization, I should write here bad indexes, add I, and return false.
Okay.
That's it. So now we covered these situations. Now, what can be considered as a good situation? Then we can return true if E equals to S length. Then I suppose it will be a sign that we successfully split all the word into the pieces,
Okay.
right? And then we return true.
Got it.
So now the last but the most interesting part, how do we do it? So we have a loop for string word from word dict. I don't use any index here because we actually don't care. We will be just checking if some word fits or not.
Okay.
So now, first of all, if the length of this word is too big that it doesn't fit to the S length,
Yeah.
then we should skip it.
Okay.
So if, let me introduce a variable word len, and which will be word length. Yep, now we say if I plus word len, let me think about it, more than S length,
Okay.
then we can just continue, right?
Yeah.
Because let me imagine this situation. We have Leetcode, right?
Yeah.
Then we pass lead, the index will be 4, let's say, all the length 8. And if we will have some word like apple with length 5, then
Yeah.
having the overall length 8 and starting index 4, yeah, it makes no sense. But for the words with length also 4, having starting index 4 plus length 4 will be fit just right. So that's good. Yeah, I'm just worried about these conditions. Sometimes it has to be more equal or this or that, and that's why I pay some extra attention to these moments.
Okay.
Yep. So now we cut off all too long words, and now we can be sure that we can take a substring from S and check it against this word. So we will do it also similarly if word not equals to S substring starting from I and
Yeah.
ending I plus word len. So we take exactly the same substring length which has word, and therefore we need to have 3 closing
Yeah.
here, right? One for if, one for substring, and one for equals. Yep. Then again we continue
Okay.
because it's just a word which doesn't fit.
Yeah. Yeah.
And now if we know that the word is fit, it means that we can really call the same helper just from the new index. therefore it will be I plus word len,
Okay.
again as word dict, and our bed indexes.
Okay.
And if we call it and we get in the end true, right?
Yeah.
If it happened that the helper returns true, we can immediately return true. I think that's it. Therefore, we will recursively go deeper, but at some
Yeah.
point, if some of these breaks will be good, then we will return to the top immediately, and actually we will return true to the whole solution. So, seems that's it.
Yeah. I think I
Let me
got the
try.
approach, but yeah, let's see. Yeah. Let's see how it goes. Let's try to run this once. By the way, how about
I
the
think,
time and space?
yeah, the complexity. I think we probably will have issues with these checks. They
Yeah.
can take really a long time for some big
Yeah.
input. But right now I cannot tell immediately
Yeah, you
how
can
to
normally
encode.
don't consider them. You can just normally say like the in terms of the recursion and all that.
Okay,
You can ignore the substring, the equals one, and
so we will traverse through all the string and potentially for every index we
yeah.
will be checking all of the words in the word dict. So if we will say that n is s length and
Okay.
m is word dict
Okay.
length, and also we need to know that let's say L is the max
Hmm?
length in word dict. Then our time complexity will be O from n multiplied by m and also multiplied by L, because we will spend time for checking of the words, and then for each word we will be checking the equals, so it will take L time checking of all these characters. But despite it is a recursion, since we use a memoization, there will be no powers, let's say, because as soon as we check some index, we know that we will not repeat the same operations for this index.
Got it. Got it.
Therefore, that's it. Yep.
Yeah.
And
Yeah. This
regarding the
looks good.
space complexity, I will write it in the same line to not jump to the next page.
Okay.
Space will be, we use only one extra data structure, which is a set of beta indexes, and potentially this set can be filled like n
Okay.
times, therefore space is really O from n. So the longer the input string, the bigger potentially can be these beta indexes. That's it.
Okay.
And as far as I know, we don't count the recursive stack in space, right?
Yeah. Yeah.
So then that's it. And since I already have the link,
Yeah. 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 The link.
let me try it. I know that it's a very popular task and I was doing it some time ago also, but let's see.
Yeah.
Probably again more than a year ago.
Yeah.
So Surprisingly, this time
Yeah.
the indentation was more or less correct.
Yeah, true. Even I was surprised.
Good. Good. Okay, let me run it. Zero S. I see. Small typo. Integer, then that's not funny. If you call a method, you need to write its name.
Hmm. Okay.
Whoa, surprisingly it worked out.
Let's see.
Yep.
Okay.
So
And
it
submit.
worked good.
Cool.
Whoa, it really works fast. And I was lying, not a year ago, just several months.
Yeah, but still, that's great. I mean, like you have
Yeah, that
converted
was
the
a good
recursion.
refreshing.
Yeah. You have converted the recursion approach to a memoization. Yeah, that's really great. And yeah, I think you have completed all the 3 tasks. And yeah, then I would say you are hired.
Thanks a lot. Thanks. It's a pleasure.
Yeah.
Yep.
Yeah, so I think we are done. So coming to the feedback, yeah, I think so. First thing which I liked was, you have come up with the brute force initially for all the questions, and you have tried to analyze them using the test cases, and then you have come up with the optimal solution. And also you have tried to analyze the time and space complexity as well, which is required. And yeah, it was good. Yeah, it went good. Yeah, that was the feedback I had for you.
Good. Many thanks. Was a pleasure and looking forward for the next sessions.
Yeah.
See you around.
Yeah. So thank you so much. Bye.
Yeah. Have a nice day. Goodbye.
Bye.